Hello friends! Are you ready to get curious about headphone batteries? In the last video when I talked about the speaker's board, I mistakenly said the headphone battery is lithium ion. But today I'm here to set things straight. It's a lithium polymer battery. In this video, we are diving deep into these batteries, a specification, structure, how they work, features, safety types, and their applications. So let's jump in and see what's up. Why is this a lithium polymer battery? Let's take a closer look at this battery right here. I hope you can see. Yes. Okay, it's got a silver, soft, and flexible body made of laminated aluminum plastic. Usually, it has a standard code printed on it, like 5023, with a voltage of 3.7 volt and a capacity in milliampere per hour. If the battery is swollen or puffed up like here, it's likely due to damage or overcharging or old age. These signs are a dead giveaway that we are dealing with a lithium polymer battery. Now let's figure out what those numbers and space on the battery are telling us. These specs are like the battery's ID cards. Let's break them down. Code 5023. What is the meaning of this code? This three-digit code shows the battery's physical dimensions, defined by industry standards. The number 50 means it's 5 millimeter thick. We mean here we have 5 millimeter thick, okay? And 20 means 20 millimeter wide, and 30 means 30 millimeter line. This compact dimension let manufacturers easily fit the battery into slim, delicate devices like headphone. Why does this matter? Because first, it needs to fit the device's space, and second, it shouldn't add extra heat or weight to the system. Capacity 250 milliampere per hours. The battery's capacity shows how much charge it can hold. Simply put, 250 milliampere per hours means it can supply 250 milliampere of current for 1 hour, or say 25 milliampere for 10 hours. For Bluetooth headphones, which typically use 20 to 50 milliampere, this capacity can give you 5 to 12 hours of battery life, depending on how loud you crank the volume or how the Bluetooth connection works. And we have nominal voltage 3.7 volt. Here we have nominal voltage 3.7 volt. Lithium polymer batteries usually have a nominal voltage of 3.7 volt, but this changes during charging and discharging. When fully charged, it hits 4.2 volt, and when safely discharged, it drops to about 3 volt, but heats up. If the voltage dips below 3 volt, it could damage the battery's chemical structure and reduce its capacity over time. Here we have HKYBOC2 code. This code probably refers to the battery's manufacturer or production series. It's like the maker's signature. Now we have some key technical features about this battery. Let me minute. Yes, we have it here. Okay, lithium polymer batteries stand out because of their unique features. At the first, we have nominal voltage 3.7 volt with an operating range of 3 to 4.2 volt. The second is a specific energy. What is that? This measures how much energy the battery holds per unit of weight. Since lithium polymer batteries are lightweight, they're perfect for headphones and small devices like drones. And the third is energy density. What is the meaning of energy density? This shows how much energy fits in a small space. That's why lithium polymer batteries are so popular in compact designs. And the fourth is self-discharge rate. Even when not in use, batteries lose some charge over time. But don't worry, the rate is super low, about 5% to 10% per month. This makes them great for devices that might sit unused for a while. We have now a protection circuit board. What is that? Protection circuit board. Let me a minute to show you. Yes, here we have it. I hope you can see. Yes. What's this thing and what does it do? That teeny board soldered to the battery is a signal cell lithium polymer protection board, often called a PCM protection circuit module. Why do we use it? Lithium batteries are super sensitive to overcharging and over discharging. If the voltage goes too high or too low, the battery might overheat, swell up, or even catch fire. This little circuit protects the battery from these three issues. The first issue is overcharge protection. What is that? Prevents charging beyond 4.2 volt. And second is discharge protection. What is that? Over discharge protection is stop discharging below 3 volt. And the third is over circuit a short circuit. Okay, what is that? Blocks excessive current draw or short circuits. How does it work? The board constantly monitors the battery's voltage and current. If the voltage gets too high or too low, or if the current spikes, it cuts off the circuit to keep the battery safe. Now we have main components on board. What are these? Okay, you can see. At the first, we have here a IC labeled with HLN 1532. Right here, you can see. This is the central IC, but it's super thin and flat. These ICs are built as chip-on-board or flat-pack assembly, blending seamlessly with the board's surface, unlike bulker gib ICs. It's a protection IC that checks the battery's voltage and signals the transistor to cut the current if it goes out of bounds. The second part is MOSFET transistor. Let me minute. Yes, we have transistor here. You can see that. Okay, it's labeled with 8205A. The type of this transistor is dual n-channel MOSFET full, and the name of this MOSFET is AO8205A or similar. It's an SOT236 package or similar because it has 6 pins. And the features of this MOSFET transistor are it's an electronic switch, perfect for low voltage switching, usually 20 between 30 volt, and it has low drain source resistance to minimize heat loss and can handle high output current up to 6 ampere per channel. And now we have here DWO1A here protection. Right here, it's really seems like transistor, but it's not a transistor. What is that? It is a protection IC. This is a battery protection IC designed to shield lithium polymer batteries from overcharging, over discharging, and excessive current. It works with an external MOSFET right here to control the battery's current. Its max charge and discharge voltages are 4.3 volt and 2.4 volt, respectively, with the overcurrent threshold depending on the MOSFET's resistance. And we have two assembly resistors labeled 102 and 101. These are typically used for sensing circuits or current limiting. 102 means 1 kilo ohm, likely for pull up for timing the IC's response, and 101 means 100 ohm, possibly for limiting the MOSFET gate current. Okay, and we have a small assembly capacitor right here. This establishes the circuit and filters out voltage spikes. It's usually the coupling capacitor with a capacity of 1 microfarad or less. Now we will look at the back of this board. The back of this board has 4 connection points. Let me minute to show you. Okay, we have P negative and B positive connect to the battery, P positive and P negative connect to the speaker board. This setup lets the circuit draw current from the battery, send it to the speaker board, and still protect the battery. The sides pad gray are for direct battery cell connection. Usually the left pad for the negative terminal and the right for the positive. Middle wires red positive output and black for negative output to the load or charge. Okay, now we should have a PCM board performance summary. We have IC with label with HLN1532. It controls voltage, current, and errors. Then we have DWO1A protections IC for watt battery protection IC. We have MOSFET transistor 8205A switch charge discharge current, and we have resistors SMD resistors 102 and 101 limit or pull up functions, SMD capacitors for filters and stabilize voltage, and battery pads direct cell connection, red and black wires output for the load or charge. And now we should have an internal structure and how lithium polymer batteries work. Let's look at that. Yes, we have it here and we have a battery here. Okay, lithium polymer batteries are different from regular batteries in structure and performance. They are made of three main components, each playing a key role in storing and transferring energy. At the first, we have positive electrode cathode, usually made of lithium cobalt oxide. This material stores a lot of energy in a small space and provides stable voltage. Then we have a negative electrode, anode, made of graphite which acts like a reliable storage tank, absorbing and releasing lithium ions effectively. And third, we have polymer electrolyte. Unlike lithium-ion batteries that use liquid electrolytes, lithium polymer batteries use a soft polymer gel or solid material. This makes the battery lighter, more flexible, and eliminates the risk of liquid leaks. How charging and discharging work in this battery? At the first, we will look at the charge. Yes, right here, and you can see it here. Okay, when you plug the battery into a charge, electric current flows in from an external source. This makes lithium ions move from the cathode, right here, through the electrolyte to the anode, where they are stored in graphite layers. Meanwhile, electrons travel through the external circuit to the anode, storing energy in the battery. When the voltage hits 4.2 volt, the battery is fully charged. Okay, we have cathode, lithium go out from electrolyte move, and then we have lithium and electron in anode. Now we came to the discharging. How discharging work? Let's look at that. Yes, we have it here. When you use the headphones, lithium ions move back from the anode to the cathode. This releases electrons in the external circuit, creating this electric current that powers the headphones speakers or Bluetooth model. Why do some batteries drain faster than others? Now we will look at that. Okay. Now let's break this down. Why do some batteries drain faster than others? Several factors affect these topics right here. Yes. Affect how long a battery lasts or why it drains quickly. At the first, we have battery capacity. The higher the capacity, like 500 milliampere per hour instead of 250 milliampere per hour, the longer it lasts. And second is battery type. Lithium polymer and lithium ion batteries store more energy in less space due to high energy density, making them great for headphones and phones. Older batteries like nickel cadmium aren't as efficient. The third is usage. Cranking up the volume using noise cancellation or keeping Bluetooth on drains the battery faster. 4 is battery quality. Higher quality batteries with better energy management hold charger longer. The fifth is temperature. Extreme heat above 40 centigrade or cold below 0 centigrade reduces battery performance. The ideal range is 15 to 25 centigrade. Battery age. After 300 between 500 charge cycles, batteries lose capacity, dropping to about 80% of their original capacity. And the last one is device settings. Background apps, constant notifications, or advanced ID modes in headphones increase battery drain. Now we will have battery life factor summary. Higher capacity, longer life. Modern batteries, better performance. Less use of power-hungry features, slower drain. Higher quality, better resistance to drain. Proper temperature, better efficiency. Newer battery, more capacity. And last one, optimized settings, less consumption. Now we will have a safety warning for you. What are that? Yes, use the right charger, as you can see here. Stick to chargers designed for lithium-polymer batteries that regulate voltage and current properly. Second is storage temperature. Store at the right temperature. Keep the battery in a mild environment, 15 to 25 centigrade, and avoid extreme heat or cold. The third is prevent physical damage. What is that? Lithium polymer batteries are sensitive to impacts, pressure, or punctures, which could cause chemical leaks or explosions. And the fourth one is charge on time. Charge the battery before it drops below 20%. Over discharging can reduce its capacity. And the last one is watch for damage signs. Sign of damage right here. If the battery sols, overheats, or smells weird, stop using it immediately. These are signs of internal damage. Dispose of it safely at a recycling center. And finally, so we have seen lithium polymer batteries with their small size, lightweight, and high capacity are the beating heart of portable devices like headphones. Follow these types and they will keep you powered up for years. Technology is moving fast and we are excited for even better, safer batteries in the future. Thanks for sticking with me this far. If you learned something or have thoughts, drop them in the comments. Don't forget to like and subscribe for more videos. Until next time, take care of yourself and your batteries. Bye!